Here I've been asked to find a polynomial function of degree 4 that has negative 3 as a 0 with multiplicity of 3 and 0 as a 0 of multiplicity of 1. Remember two things. Polynomial function are terms that are either added or subtracted. Second thing, multiplicity basically tells us the power on the factor that I receive my 0 from. And so on here, what I'll do is I'll start off by saying f of x. That will represent my function. Don't worry so much right now about the degree of 4. Later on, when we actually get our answer, we'll make sure that that part is satisfied. It says that negative 3 is a 0. Well, if negative 3 is a 0, then what is a factor? X plus 3 is a factor. What does it mean to have multiplicity of 3? That means that that factor has a power of 3 on it. So the first factor would be x plus 3 to the third power. Then you will multiply whatever other factors that you find. The next piece says 0 is a 0. So if 0 is a 0, what does that mean? That means that we have something along the lines of x as a factor. It has multiplicity of 1, so it would be x to the first. So our second piece is x to the first. Now notice here it says find a polynomial function. There actually might be multiple values that would work as this particular factor. You could actually put constants in front, so we could have 10x to the first. This over here could be 20x plus 3 to the third, but I'm not going to use those constants. We're just going to make things be easy. They wanted me to find a polynomial function of degree 4 having these requirements, and so this is as simple as I can get with that. Now, polynomial means sum and differences of terms. This is a product. This is not sums and differences. So what I'll have to do is I'll have to expand it out. Now, x plus 3 being raised to the third means that x plus 3 is multiplied times itself 3 times. Okay, and I still have this x back at the end. What I would do is I would do this by pieces. I would FOIL those two pieces together, and then I would take this x and I would distribute into here. So do those two pieces. So FOILing the first two, I would get x squared plus 3x plus 3x plus 9. That's still in parentheses, and then multiplied, distributing the x, I would have x squared plus 3x. There are some terms in the first group that I can combine, so x squared plus 6x plus 9, and then I'd be left still with the x squared plus 3x. Now, to multiply these two groups together, I can't FOIL because I have more than 2 terms in the first group, but what I can do is I can basically multiply x squared by each of these terms, and then multiply 3x by each of these terms. And I should have a result of 9 total terms. X squared times x squared is x to the fourth. X squared times 6x is 6x to the third. X squared times 9 is 9x squared. 3x times x squared is 3x cubed. 3x times 6x is 18x squared. And then finally, 3x times 9 is 27x. As your last step, combine any like terms. We have an x to the fourth, and then we have some x cubes. It looks like 9x cubed. We have some x squared terms, so 27x squared. And then it looks like we have only one x term, which was the 27x. Now, this is our final polynomial function. Notice that it does have degree 4. When we look here, the highest power on our x is to the fourth. And then because of the way we built it, when we originally built the function at the top, notice that negative 3 is a 0. It has multiplicity of 3. 0 is a 0, it has multiplicity of 1. So we have fulfilled all the requirements of this problem.